Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to create an AUC ROC curve. So this is what we'll cover in today's video. I will go over what does ROC AUC mean. AUC ROC mean. I keep switching them about. And we'll talk about how to use .plot ROC curve function. We'll talk about how to use estimator method for ROC AUC score. We'll talk about prediction method for ROC AUC score and visualization. I'll show you how to manually plot ROC AUC score without using the estimator and prediction method. And we are gonna plot ROC AUC score for random forest model. And we're also gonna plot it for linear regression model. So I'm gonna show you how to plot the ROC AUC score for linear regression and random forest model in the same graph. So if you're comparing two models, you can quickly see which one has a better AUC score, which one has a better ROC curve, and then I'll show you how to get the AUC score without plotting ROC. So this video is gonna be a little bit longer. Go ahead and grab a popcorn, sit back and enjoy. So above here I have two models, CVRFC and LRC. LRC is the logistic regression model, and CVRFC is a grid search CV, and the model, the estimator, is the random forest classifier. So I wanted to make that clear because we're going to be using LRC and CVRFC in this tutorial, and I want to make sure you know what it is up front. So let's first begin by going through what is ROC AUC. So this is the documentation for ROC curve, and this is the documentation for ROC curve. You can look at this documentation later. I'm gonna put this in the comment section below. And so what does ROC AUC mean? So AUC means area under the curve, and ROC means receiver operating characteristics. And I keep saying ROC AUC, and it's also AUC ROC. Like sometimes I get it backwards, but you know what I mean. So area under the curve, AUC, is the measure of the ability of a classifier to distinguish between classes, and it's used as a summary of the ROC curve. The higher the AUC, the better the performance of the model at distinguishing between positive and negative classes. And you can find most of this on Wikipedia, but I just wanted to give you an idea of what it is up front here. And here's another documentation on ROC and receiver operating characteristics. I'm going to add this Wikipedia page to the comments, to the description of this video. So what is receiver operating characteristics, ROC? ROC plots the true positive rate on the y-axis against the false positive rate, usually on the x-axis, at different thresholds, which is different values. And AUC calculates the area under that curve. So higher AUC means a better model. So a higher AUC means that the number of true positive is increasing or remaining steady as the threshold gets bigger. And according to Wikipedia, the true positive rate is also known as the sensitivity, recall, or probability of detection. And the false positive rate is also known as the probability of false alarm and can be calculated as 1 minus specificity. And so think of sensitivity as a true positive rate and specificity as the true negative rate. And true positive rate refers to the probability of a positive test conditioned on being truly positive, and true negative rate is the probability of a negative test actually being negative. So when they do the test and you get something back that says positive, the probability of it actually being positive, that's true positive rate. And when it comes out negative, when your result comes back negative, the probability of that result being actually negative is the true negative rate. So here's more documentation and ROC documentation on ROC, and here's a good blog that talks about ROC AUC explanation. And according to this article right here, one way of interpreting AUC is as the probability that the model ranks a random positive example more highly than a random negative example. So if you want to kind of understand a little bit more about the meaning of ROC AUC and what they mean and how to calculate it, you can look at these documentations. And yeah, I hope it helps you. So now that we've gotten that out of the way, let's go ahead and move forward. So if we go up here, you see that I have this from sklearn.metrics, import plot ROC curve, ROC curve display, ROC curve, AUC ROC, AUC score. So these are the things we are gonna need. Make sure you have them imported as you are doing this. So I've already run this code. I've already imported these things. Let's go ahead and show you how to use .plot ROC curve function. So what I'm about to show you is a deprecated method, and this is the documentation for it. And this has been this plot ROC curve is deprecated. I'm gonna show you how to use it anyways, but I'll show you the new way to calculate ROC curve after showing you the deprecated method. So to save a little bit of time, I'm not gonna type out everything, but I'm gonna explain the code as we go. So here it says plot an ROC curve and the logistic regression AUC ROC AUC curve. So here we are just saying LRC plot is equal to plot ROC curve. That's this deprecated method here. And the first thing you provide is a model, and this is logistic regression model. And then you provide your S test, and then you provide your Y test. That's the syntax for this particular function. So if we go ahead and run this, right there we have an ROC curve and then an AUC score. And then as you can see right here, it says that the plot ROC curve is deprecated. And from here, it suggests that we use ROC curve display instead of using plot ROC curve. So let's go ahead and do that. Let's go ahead and use the ROC curve display function. So the ROC curve display estimator, the ROC curve display function has like different methods you can use. It has .estimator method and it has .prediction method. So first, let's go ahead and try out the .estimator method. So what I'm doing here, I am going to use the ROC curve display .estimator method to get the AUC ROC score for linear regression model. And here's the documentation for that, which I will include in the description below. So to create an ROC curve using the estimator method, this is the syntax. The syntax is basically you do ROC curve estimator.estimator, and then parentheses you provide the estimator, which is your model. You provide your X data, and then you provide your Y data, right? And this ROC curve display is coming from here. I imported ROC curve display. So let's go ahead and run this. And when we run it, we get the exact same result that we got above. So when we use the deprecated plot ROC curve, we got an AUC score of 0.89. And that's also what we got here with the ROC curve display dot from estimator method. Now, this AUC score is accurate for the model that I have, but that doesn't mean my model is accurate. So the model that I have built here is just a simple, what I call nonsense model. It's not like the model itself is not a very good model. I just built it for tutorial purposes. The AUC score is accurate for the model, but that doesn't mean the model itself is accurate. So just keep that in mind. So that's how you will use .estimator method from ROC curve display. You could also get the AUC ROC curve from your Y predictions. So in this situation, we are inputting the model, the S test, and then the Y test. But you could also get it from your predicted values. So let's move on to using .prediction method for ROC AUC score and visualization. So this is I'm using ROC curve display dot from predictions. And once again, this is the documentations on that. So same thing, this is the syntax you provide. You do the predictions and you provide Y true, your true value, and Y pred, your bread value. So let's go ahead and run this. And that's what we got, and the AUC score is 0.7. So what we got here from dot predictions is not exact, doesn't match exactly what we got when we use that from the estimator method. So once again, like I said, the model that I built may not be very good, so may not be very good at making predictions. But I just want to show you how to use that from predictions method. You provide your true value, then you provide your predicted value. If I was actually using this for a real project and not just like a toy project, I would use the dot estimator method instead of the dots from predictions method. So you could also manually plot ROC AUC score without using a dot estimator or dot prediction method. So when we use dot predictions method or dot estimator method, some mathematical calculations are going on in the back scene. We don't really see these things, but you could also replicate those mathematical calculations and manually plot ROC AUC score yourself, kind of do the calculations yourself and plot it without using any method. So I will quickly show you how to do that. So basically, the syntax for manually plotting ROC AUC score yourself is providing the false positive rate, the true positive rate, the ROC AUC score, the name of the estimator, and then the positive label. And FPR stands for false positive rate. Let me make this easier to read. So that's what this acronym means. ROC AUC means area under the curve, and these are the other things. So once you have all this information, you could manually calculate your own ROC AUC score. So this is the code of how to do that. So first we calculate the false positive rate and the true positive rate, and we can calculate that using the ROC curve. ROC curve is a method I imported above when I showed you that. And when you use ROC curve, the output is the false positive rate, the true positive rate, and the thresholds, right? So we put ROC curve is equal to y test spread, and this ROC curve expects to you to provide your y true and your y test in order to give you predictions, right? And then we calculate the ROC AUC score, and the ROC AUC data is equal to AUC function, and then you put in your false positive rate here and your true positive rate from here, and then you graph the display, and the display is gonna be ROC curve display, and the FPR is equal to false positive rate, the TPR is true positive rate, ROC AUC is this right here, then the estimator name is LRC. So the estimator name is just the name that you want to give your estimator, not necessarily the name that you gave the model, the estimator model, but just the name. So this could be you could change this to logistic regression. So you do display.plot and then pl2.show, and then you run this, and as you can see, it gives us the exact same thing that we got here. So from here, when we use dot predictions method, we provided the y test and then the predicted y test, predicted values from y test. And here, when we calculated it manually, and we provided the y test and predicted values from y test. So that's how you manually calculate your ROC curve. Kind of using ROC curve display. So you could also take this right here and print out the actual values. Like if you're curious what is false positive rate, true positive rate, and ROC data values are, you could print them out yourself. And if we go ahead and run this, you can see false positive rate. This is our false positive rate, true positive rate, and then the ROC AUC score, and then thresholds. So right here it shows like only 3 thresholds, 0, 1, and 2. That's probably why the graph looks so funky. Like I said, the data that I use to build this model is kind of sketchy. It's like the model itself is not good to start with, but I think it gets the points across still. Let's go ahead and plot ROC AUC score from random forest model. So far we've been doing ROC AUC score from a logistic regression model. Let's go ahead and do the ROC AUC score from a random forest model. So I'm gonna use that from estimator method, and like I showed you earlier, I have a model called CVRFC that I already built, and that's what the model looks like. And the AUC score is 0.99, which means the model is kind of perfect, and it's close to perfect. And like that worries me a little bit. I'm like, a perfect model, it's a little bit sketchy. Like if I get a 99% accuracy, that kind of makes me squeamish. It kind of makes me like worried my model is wrong, So like I said, I don't trust this model, but it gets the points across. By the way, if you add a semicolon at the end here, it should take off this display. So let's go ahead and run that. As you can see, that thing is gone. So adding a semicolon gets rid of it. So now let's go ahead and plot linear regression model, and let's go ahead and plot the logistic regression model and random forest model score on the same graph. So far I've shown you how to plot them individually. Let's go ahead and combine them into one graph. I just realized I have a mistake here. Earlier when I said plot linear regression, I actually meant logistic regression. So I just changed this from linear to logistic regression. That was a typo on my end. So let's go ahead and plot both of them on the same graph. So basically we are doing plt.figure. plt stands for matplotlib.pyplot. I imported it earlier in the notebook. And then this is just defining the figure size. This is width times height. And then I'm doing ax equal to plt.gca. And then this is a random forest model. So basically I'm doing ROC curve display dot from estimator. I'm providing these values. And then I do ROC curve display dot from estimator, and I provide the values for the logistic regression model. And this is the values for the random forest model. And let's go ahead and run this. Voila, there we go. So you can see, well, it says grid search CV. The grid search CV is the estimator that is using. The grid search CV is using random forest model as its random forest regressor as its estimator. So when you see grid search CV, think random forest. So as you can see here, the grid search CV is the blue one, and the logistic regression is the orange one. And obviously the random forest model is much better than the logistic regression model. So as we can see, the random search CV model is much better than the logistic regression model in this situation. So can you get your AUC score without doing an ROC curve? The answer to that question is yes. So let's go ahead and I'll show you how to get the AUC score without plotting ROC. And this is the syntax. You just do ROC AUC score, and in parentheses you put in your Y true, and then your Y score, your Y predicts. And here's the documentation on it. So let's go ahead and get the ROC AUC score for our logistic regression model. And this is the syntax, like I said, ROC AUC score, and then in parentheses you put in your Y test. That is your true value, and then your predicted value, Y true and Y score. And Y score in this situation is your predicted value or your target scores, right? So if we go ahead and run this, we get 0.7 as our ROC AUC score. That's not different from what we got here when we use the dot prediction method. And for the random forest model, similar thing. We run it and it gives us 0.89. So you can obtain your AUC score directly without plotting an ROC curve first. So as you might have noticed, there's a difference between the ROC AUC score, the AUC score, and graph, from like when we use dot prediction method versus when we use dot estimator method. And I think this error could be from my graph, or it could be that I'm using it wrong. If you think I'm just using this wrong completely, let me know in the comment section below. I'm not perfect. I'm constantly learning. Sometimes I do get things wrong. So yeah, that's basically it for this video. That's all I've got for this video, and let me know what you think in the comment section below. I'm really interested. And if you want to get access to the notebook I used in today's video, just go to machinelearningeducation.com/free. Here you get access to this notebook and get access to any other notebook that I've used in tutorials on my YouTube channel. I like to keep everything in one location because it just makes it so much easier to organize everything and make it available to you. So just go to machinelearningeducation.com/free to get access to this notebook and other notebooks that I have available. That's it for this video. Thank you for watching, and I'll talk to you on the next one. Bye.